this is going on page 95 when we are done. Okay. So our first definition, blank is a polyhedron formed by two polygonal, parallel, congruent bases which are connected by lateral faces that are either parallelograms or rectangles. What goes in this blank? A prism. Good. This is the definition of a prism. And today we are going to look at surface areas of prisms. Right? Now, the actual definition of a prism just says the lateral faces are parallelograms, because if I stop there, doesn't that take care of rectangles also? Like a rectangle is a parallelogram. But I wanted to put them both on there just so that you didn't get them a little mixed up right there. Okay, I know that surface area is not brand new to you, but the way that you have done surface area in the past is either by finding the area of each separate piece from the net and adding them up, or by taking stuff and just plugging it into a formula that you have no idea where it came from. Am I right about that? Okay. So it is important to me, even though I know it's not always important to you, it is important to me for you to understand where things come from and why. Because believe it or not, if you're actually paying attention and trying to learn this stuff, it will help you remember it later on down the line. Understanding a concept instead of just memorizing formulas makes you understand the big picture of things, and you're able to connect and relate things together a little bit better. Okay, so we have this prism here. So this is a rectangular prism. Could possibly be a square prism. It kind of looks like it, but we don't know that, so we're going to go with rectangular prism, right? And then we have two different things laid out here. This is the full net that includes the bases. This is the net that just includes the lateral faces. Now, for the most part, if you know what you have is a prism, then what the bases are the things that aren't the rectangles. But for a rectangular prism, they're all rectangles. So really, any of them could be the base. And if you're finding the volume, it won't make any difference. If you're finding the total surface area, it won't make any difference if you and I use a different base. But if you're finding just the lateral area, it does make a difference, because the lateral surface area is you not including the bases. So it makes a difference. So for just the general way to handle things is that if you have a rectangular prism, then the base you use is what it's actually sitting on in the picture, just for consistency purposes. But in reality, it could be any of them. Okay, does that make sense? It could be any of them. All right, so we have this, and this ABCD represents the side lengths right here, and then this is H right here. H represents the height. Okay, and if I unroll this and just take the lateral faces and lay them out right here, A, B, C, and D come from right here, right? So if I add these up, if I take all these and I add A plus B plus C plus D, what piece of information about the prism would that give me? Good. It's the perimeter of this, which would represent the base. Does that make sense to you? That is the perimeter of the base, because you just add up all the pieces. That's what happens. So here's my net. I unroll it. I wrap it back around. It's the perimeter of whatever the base is. So this is P. And it's a capital P because it is something that we have calculated. So P doesn't just represent perimeter. It's the perimeter of the base. It's not the perimeter of whatever you want to find the perimeter of. And it's not just you adding up whatever numbers you see, which is I see that sometimes too. I don't get that. Now, I know that in the past, one way that you have done lateral or even total surface area is unwrapping it, finding all the pieces and adding them up. But that gets way more complicated the more complicated the figures get. So I could find the area of each rectangle here and add them up. Or when I unroll it, doesn't it just make a big rectangle? Right? One big rectangle. If this base was a hexagon instead of a rectangle, would this still unroll to give me a rectangle? Yes, I just have more of them there, right? There's just more that would unwrap. So I can find the area of a rectangle. We're pretty good at that. So if I add all these pieces up, that's the perimeter of the base. This right here, which is the height of my rectangle, is also the height of the prism. It's still H. Does that make sense? So this is H. Now, to find the area of a rectangle is just equal to base times height, right? So that's how I would find the area of this rectangle right here. but the area of that rectangle actually represents the lateral area, which we're going to represent with LA. Sometimes it's represented with just L. You'll see it both ways. I think your textbook just uses L, and that's why I started trying to do that. But LA for lateral area makes a whole lot more sense. But know that it could be represented on some formula charts. Here's the other reason why it's important to understand the concept, because sometimes the formulas look different on different formula charts. Okay, given from a different book, or if it's on the SAT or whatever, it could have an S, which represents surface area, and it could say lateral surface area. So sometimes S represents surface area, total surface area, and lateral surface area, and those are different things. So you still have to understand what you're looking at, even if you're given formulas. So instead of using little b for the base length is the perimeter, which is capital, and the height is the height. Okay? We good with that? So what this tells us here is that the lateral area, just using the lateral faces, is the product. What does product mean you do? Multiply. Right? The product is the result of multiplication. It's the product of the perimeter of the base, not just the perimeter of anything, and the height of the prism. Again, not the height of whatever you want to find the height of, but the height of the prism. In this case up here, the height of the prism and the height of that rectangle happen to be the same. And this is like, you can just ignore that. That was something that should have worked out, because that word was supposed to go down here. This should say lateral area formula. So lateral area is equal to perimeter times height. Way easier than unrolling it and finding a bunch of different things. Okay? All right, so let's go up here and look at the net for the total. This part here represents the lateral area, which we already know how to find. And then this is a base, and this is a base. So regardless of what the polygon is, in this case it's a rectangle, I know how to find the area of a rectangle. If it was a regular pentagon, I know how to find the area of a regular pentagon. Like, we can find the area of the polygons. I know how to find the lateral area, and then I just have to add to that the area of the two bases, and that gives me my total surface area. How do I represent the area of the base? What letter do I use for that? A big B. Yes, absolutely. So down here underneath this last line, this capital B. This is why capital and lowercase, it's so important that it's not just a handwriting thing. They mean different things. A capital B is the area of the base. The lowercase b represents a length of a base that I can go and just measure. But the capital B is a calculated area, and that's what it represents there. Okay? So the surface area, or the total, sometimes called the total surface area, it doesn't have to be, it can just be called surface area. So sometimes you have lateral area and surface area, and sometimes it's referred to as lateral surface area and total surface area. So make sure you understand that you can hear it two different ways. Is the sum. Sum means you do what? Add. Okay. Of the lateral area and the area of the bases. So since my prism can have a base that's any polygon, I can't be specific about what that formula looks like. That's why we have to use big B to represent whatever it may be. And so your total surface area, so sometimes it's total surface area, could be surface area equals, well, what this says right here is the lateral area plus, how many bases are there? 2. 2 times big B. Or you could use surface area is equal to perimeter times height plus 2 times big B. They're the same thing, right? All I did here was substitute in perimeter times height for the lateral area. So this doesn't mean I'm multiplying L times A. That's actually a lateral area there. It depends on what the question is asking you for. If you're asked to find the lateral area and then also ask for the surface area, then you probably want to use this first one because you already have that. You don't need to recalculate it. If all you're asked for is the total surface area, then you might as well use the second one and plug it all at the same time. But you could still use this one and do it in pieces. It doesn't matter. We good? Make sense where it's coming from? Right? Okay, math is not just something that somebody sat down and decided, you know what, I'm going to make them use this formula to do this today. No. It has to actually make sense for what you're doing. All right, so some quick definitions here. The base of a prism is one of two congruent parallel faces. So this rectangular prism I have in my hand has a total of 6 faces. 2 of them are bases, and then the other 4 are lateral faces. Okay, so it's just a base is a special kind of face, is all it is. And then the blank is a face of a prism or pyramid that is not a base, or in other words, the sides, but remember, it really could be the bottom. That's kind of not a, put those in quotes, I don't really like that. But this is called lateral face. Lateral kind of meaning side. Think about a lateral pass, right? It's not sideways, right? So it's kind of the sides. All right, so then blank is a segment with its endpoints on the planes of the bases that is perpendicular to the planes of the bases. So the word segment here is important. With its endpoints on the planes of the bases that is perpendicular to the planes of the bases. So what do you think goes in that blank? Well, an edge doesn't always have to be perpendicular. What always has to be perpendicular to the base? Height, okay? But height is actually not what goes in this blank because it starts with an, right? That's probably why edge came up because it starts with a vowel. That's good English thinking there. What actually goes in this blank is altitude. Okay, that word you've used for height before, right? So here's the technicality of all this. The altitude is the segment. The segment itself is called the altitude, but the length of the segment is the height. So the altitude is the segment itself, the height is the number. That's the only difference. They're used interchangeably, and nobody gets really nitpicky about that, but I do want you to know the difference. But here's what I really want you to think about what the height is. I mean, this is the technical definition, and it says endpoints on the planes of the bases to allow for when it's drawn on the outside. But I want you to write up here that height, okay, is the distance between the bases. That is so important. It sounds so simple and so obvious. That is going to really mess some of you up. The height of the figure is not necessarily how tall it is on the piece of paper. Okay? Do you know how tall you are? Okay. So Omar's 5'7", right? But right now, if I measured him, is he 5'7"? No, right now he's not. I mean, he is, but like his height right now, for the distance from the floor, but that's not his height, right? What if he stood up? There you are. He's 5'7", right? If he lays down on the ground, is his height now like 6 inches or however far he'd be off the ground? No, he's still 5'7". Like when a baby is born and they give their length, usually not their height, but it's the same thing. They just can't stand up, right? What do? They lay the baby out, and on a piece of paper, they mark the end of the feet, and they mark the top of the head, and that's the baby's height, but we call it the length because they're not standing up, but it's the same thing, right? So the height is the distance between the bases. Think about measuring a baby on a table. It's the same thing. If you could stand them up, you'd do it a different way. It's not like when you go to the doctor now, he makes you lay down on a big piece of paper, right? Now you're big girls and boys, you get to stand up on the wall and they measure you, right? He does it to you. It's a really long piece of paper. So height is the distance between the bases. Don't think of it as how tall it is, all right, because that's a different way of thinking. All right, and then an edge, that's what goes in this one right here. An edge of a three-dimensional figure is a segment that is the intersection of two faces. Okay. Now, we've got these two different types of prisms. Besides the fact that one of them has the base that's a pentagon, and one of them has a base that's probably a rectangle. We can't really tell, but it's a quadrilateral anyway. There's also a difference between them, right? Because this one looks like it's standing up straight, and the second one looks like it's leaning over. Would you agree with that? Okay, so the one that's standing up straight has rectangles as the lateral faces, and that makes it a right prism. It makes it a right prism because it would be perpendicular to the ground. Okay. This one is leaning over, and so it is an oblique prism. Where else have you heard the word oblique? It's a muscle. Where are your obliques? None of y'all know? That's not your butt. Those are your glutes. Your obliques are here, right? When you're working out your abs, you can work out your obliques. Because you know what your oblique muscles allow you to do? Lean over. That's why that's called an oblique prism. It's not like a random word, okay? And that's going to come up in other things. Like, so everything does relate. It's the same word, right? So oblique means that it's leaning. That's not the exact definition, but that's what your oblique muscles allow you to do. So that's how you can remember what it is. All right, so to label these things, these two are pointing to the bases. This is not doing a great job of pointing because it kind of looks like it's pointing to a base, but I'm really trying to get it to point to like here so that it's a lateral face. Then this is a lateral edge. Because it's where two lateral faces come together. And then this right here is a base edge because it is an edge of a base. It's not where two bases come together though, because that makes no sense. And because it's a right prism, well, you can't really see that. That is a right angle right there. And then the oblique prism, this over here shows you why the definition has to say that it connects the planes of the bases, because sometimes the height can be drawn on the outside. I could draw the same height on the inside like this. It's the same thing. It's just like with a parallelogram or a triangle that you've done before. So the value of this length is the height, but the segment itself is called the what? Altitude. We all good with that? Yes. All right. So let's look at the surface area of a cube. Now, is a cube a prism? Yes. It is a square prism or a rectangular prism, so it's still a prism. And you can still use that formula that goes along with it, all right? But there's also simpler formulas. But when it comes down to it, instead of, if you're not a formula person, which most of us are not. I mean, there are some people that can remember all the formulas and they're just like clicking away in their brain. And that's you. Just keep it to yourself because nobody wants to hear about it. But I'm just messing with you. We're proud of you, but you make us sick a little bit. So, we're just jealous. That's what it is, really. But anyway, instead of memorizing like 1,000 different formulas, have the basic concept and you can apply it to everything. Or if you had to come up with this formula, you can use what you already know to come up with that. So it tells us that the surface area of a cube with edge length S, okay, is blank times blank, whatever. So the formula for the surface area, okay, so I want the surface area. I know it's a prism, so I can say, well, I know that the surface area is equal to the perimeter times the height plus 2 times big B, right? So I got to find the perimeter of the base. Well, it is a regular polygon because it's a square, right? So isn't the perimeter just n times s? What's n? Number of sides, which is 4. And what's the side length? S. So your perimeter is really 4s, right? And then I got to find big B. Well, big B, either you know the area formula for a square. What is it? It's base times height, right? Which is s squared. Yeah, so s squared. So you have big B and you have the perimeter. So we can come up here and plug it in. And I get the perimeter, which is 4s, times what's the height of the prism? S, plus 2 times big B, which is s squared. So what's 4s times s? 4s squared plus 2s squared. So what's your surface area? 6s squared. Now, is there another way we could have come up with the formula? Yeah, there's 6 squares. They're all the same. So 1 square is s squared. I multiply it by 6. It's the same thing. You get it either way. So the surface area of a cube with edge length s is 6 times the side squared. But if I didn't need the formula and I had numbers, even if I plugged in actual side lengths, I'd get the same answer if I used this either formula I used. Okay, we good? All right, let's look at the next one. So this says, find the lateral area and surface area of the right rectangular prism. So if I just gave you the picture, you don't know it's a right prism and you don't necessarily know it's a rectangle. You know it's a quadrilateral, but it tells you that right there, so we're not assuming anything. Now, remember, it's not always necessarily going to be sitting on its base. I think I did give these two, or at least the second one to you that way. So this one, I could use this as the base, but if it's a rectangular prism, then for consistency purposes, we're going to use what it's sitting on. So this is going to be the base of my prism. Okay. Then I'm going to go forth and do what it asks me to do. It asks me to find the lateral area first. So my lateral area is equal to the perimeter times the height, right? Now, is perimeter going to be n times s? No, because it's not a regular polygon, right? So my perimeter instead, yeah, there's formulas, but sometimes it's easier just to add things up, right? I'm just going to add up numbers. What numbers do I add up? 8 plus 6 plus 8 plus 6, right? Don't do 6 plus 8 plus 12. I see that all the time. That ain't the perimeter of anything, right? And if we're talking about the perimeter of the base, so this is 8, this is 6, that makes this 8 and this 6 because it's a rectangle because it told me it was. So when I add all that up, what does that give me? 28. So I come back over here and substitute it in. My perimeter is 28 times the height, which is what? 12. So my lateral area, okay. So what's 28 times 10? 280. And then 2 times 28 is 56. So this is going to give me what? 336. Good. That's going to be centimeters squared. That is my lateral area. Everybody good with that? All right, so now I'm supposed to find the surface area. So my surface area formula, I've got 2 of them, but I already have the lateral area, so there's no need to go find it again. So my surface area formula I want to use is lateral area plus 2 times big B. So I have to go off to the side and find big B, but you always, always, always need to write down your big B formula. Your big B formula is dependent on the shape of the base. Big B is not always going to have the same formula because not always the same formula is going to apply. This base is a rectangle, so what's the area formula for a rectangle? Base times height. Okay. So, what are the base and the height of the rectangle? 8 times 6, right? Or 6 times 8, doesn't matter. So big B is 48. Okay. Now, notice this. We have this height, I used 6. We have this height, we used 12. Those are 2 completely different things, right? This is a 3-dimensional formula right here. This is the height of the 3-dimensional figure. This is a 2-dimensional formula. This is the height of the 2-dimensional figure, right? You're talking about different things. So don't go substituting it in just because it said H, right? Because that can throw you off sometimes too when you're not paying attention to what you're doing. All right, so now I go and substitute all this in. I already have that, so I can substitute in the 336. 336 plus 2 times 48. So that's 336 plus, what's 2 times 48? 96. So when I add these together, you know the easiest way to do that? Add 100 and subtract 4, right? So that gives me 436, which would change to 432 centimeters squared. Everybody okay with that? Any questions at all? Nope. All right. So let's look at this one over here. This says, find the lateral area and surface area of the regular hexagonal prism. So I can look at that and know it's a hexagonal prism, But they have to tell me that it's right. Well, it doesn't even say that. Yeah, the fact that it's well, it doesn't say that it's a right prism, but it is okay to assume that on these because that's all I'm going to give you right now. So they're right prisms. But then you can't assume that it's regular, but they told me that, so that's good because I need to know that, right? So I need to start by finding the lateral area. So my lateral area formula is perimeter times height. So I know that perimeter for a regular hexagon is n times s, right? What is n in this case? 6. Do I know s? Yes, it's 6. So the perimeter is 36. Do I know the height? Yes. So this is going to give me 36 times 10. So my lateral area is 360 meters. Everybody okay with all that? All right. So now I need the surface area. So surface area, I'm going to use the same formula I did over there because I already have the lateral area. So lateral area plus 2 times big B. I already have that. So my big B formula, is it going to be base times height? No. What's it going to be? How do you find the area of a regular hexagon? 1/2 apothem times perimeter. If you thought you could avoid those when we were done with them, you were sorely mistaken because they're going to be around for a long, long time. Bless you. All right, so I go back up here. They didn't give me the apothem, right? So we always start by drawing in 2 radii and that's really hard to draw on this one right here, right? What's your central angle? 60, right? Because it's 360 divided by 6. And then I'm going to take that triangle and I'm going to redraw it out here because there's no way in heck I can actually do that. So when I do that, this represents the apothem. Notice I took the entire triangle out, not just part of it. This whole side length here is 6. And this whole angle here is 60. And so that means that this is 30, this is 60. What's my apothem? 3 square root of 3. Good, because if this is 6, that makes this 3, and this is 3 square root of 3. And if you cannot label the special right triangles quickly like that, you are going to be in a world of hurt because this is just going to keep on hitting you. And some of you just keep on missing that and missing that and missing that, and you still don't even understand how they work. And regular polygons, you didn't do the homework, and you didn't get them right on the test, and you still don't know what you're doing, and that's going to make this really, really hard. Okay, so I have found all this stuff. I'm going to come back and plug it in. I've got 1/2. The apothem I just found is 3 square root of 3. Do I need to go calculate the perimeter? Now, I have a perimeter here, right? But I got to be careful because over here, this H and this H weren't the same. Is this P and this P the same? What's this the perimeter of? The hexagon, right? And that's what I need right here, right? So if you already have it, use it. There's no reason to go do it again. So that's 36. So I would like to take 1/2 of 36, which would give me 18, times 3, which would give me what? 54. So it's 54 square root of 3. So now I come back over here and substitute this in. I already have my lateral area. It's 360 plus 2 times big B, which is 54 square root of 3. So then that gives me 360 plus 108 square root of 3. Then will that give me 468 square root of 3? No. We should be way past making that mistake. Parentheses and meters squared. Any questions at all? Alrighty. Now I want you to look at this picture down here. And we're going to talk about the surface area of the composite figure. Now, there is a way to do this where it's not a composite figure. If I wanted to look at this as one full thing, what kind of prism is this? Trapezoidal prism. Because you have two congruent parallel trapezoids, right? So it's a trapezoidal prism. So we could find it that way. But I was trying to find a figure that wasn't too crazy that we could do composite area on. So we're going to treat it like a composite figure and pretend like it's not a trapezoidal prism. And by that I mean, can you see how you would have two different prisms put together? You see the rectangular prism and the triangular prism? Does that make sense? Okay. So I want you to think for a second, not as far as, what the answer is or even formulas or anything, but just a plan for how you would go about, like, what would you find? Would you find the, total of both of them and add them together or whatever? And I don't want the plan to be like 1,000 pieces added together either. So I just want you to think for a minute how this actually works and when I want the total surface area of what's happening. And remember, this is like an empty box, right? If I am down here in this rectangular prism, I could freely get up into the triangular prism. There's no floor there, okay? So think about what your process might be. I'm going to give you a second to do that while I go check roll. Okay, so let me ask you this. Could I just go and find the total surface area of both prisms and add them together? Would that give me the surface area that I want? No, okay, because I'd have a problem, right? So could I do that? I mean, could I find both total surface areas? If I did do that and add them together, what would I need to get rid of? Mariah, read, sit up. I'm sorry, what? The middle, like the shelf right here, right? So I could say I could find the total surface areas and add them together and then subtract what? 2 or 1? Okay, look at my two total surface areas. You have to pretend like that has a bottom on it. So, and I know they're not the same shapes, but I'm going to put these together, right? They're my total surface areas. If I take off this base, don't I still have a problem here? One of the problems is I can't hold all this and do this at the same time. Okay, you see I still have a problem? How I still can't get in there? Because if I find the total surface area of both of these and add them together, there's a rectangle here that belongs to the top prism and a rectangle that belongs to the bottom prism. So there's 2 layers there. Picture taking 2 boxes and literally putting them together. If you just cut the hole out of one box, you still can't get in the other one, right? So I would have to subtract 2 rectangles. Does that make sense to you? Everybody okay with it? You understand why we have to subtract 2? Okay, now there's another way to do it, and we'll talk about that in just a second, but let's write this down. So here's 2 different plans. Okay, so my first plan is I'm going to find the surface area of the triangular prism. I'm going to add to it the surface area of the rectangular prism. Okay. And then I'm going to subtract 2 rectangles. Right? SA or S, it doesn't matter because it's not really formulas, it's just a plan. Okay. Everybody okay with that? Could I do something where I only add 2 things together and don't subtract anything? I just want to find 2 things, add them together, and not subtract anything. And I'll tell you, as far as this stuff goes, because this is very basic compared to some of the crazy figures we will get to. And it's harder for some people to wrap their minds around the pure just addition with no subtraction. It's way easier for the people that struggle to find everything and subtract off what you don't want. That's the go-to way if you get confused with it. But there are other ways that people think through, because again, some people can just visualize this stuff. Let's say that I'm going to find the total surface area of the triangular prism. What can I add to that? So I just add one more thing. Good. The lateral area of the rectangular prism. So I want you to just think about that for just a second, and I'll explain to you how that works. See if you can figure out why that would be okay. So think about it this way. We find the total triangular prism, right? We put the lateral area of the rectangular prism on it, which is just the walls. So then I have 2 problems, right? I don't have a floor, and I have this ceiling that I don't want. Well, couldn't this ceiling just drop right down to the floor? Because this rectangle that I don't want here takes the place of the one that I need here. Okay, so that's kind of minimizing what you have to do. It's not necessarily minimizing the work that much. It's not taking away so much work that it's super important you understand that process, okay? It's fine if you have to always find everything and subtract. Sometimes that's the only way you can do it, is find everything and subtract things off. But those are 2 different ways to do it. You need a plan. Yours can be kind of written out differently than mine. You could add them in a different order. You could, represent it differently, but it needs to be something that I could look at and know, oh, that's their plan and that's what they were going to do. So we're going to do this first one because, again, I think overall that's going to make the most sense to everybody. So we're going to start with the surface area of the triangular prism. And so I'm going to just start with perimeter times height plus 2 times big B, which means I need the perimeter. What numbers do I add for the perimeter for the triangular prism? 4 plus 2 plus 4 plus 2? No. 4 and 3 and 5. Because for the triangular prism, the base is the triangle. So it's 3 plus 4. Where's the 5 come from? It's the hypotenuse. Good. And if you don't know it, and it's not a 3, 4, 5, or you don't know what, to just know that, it's Pythagorean theorem and you figure it out. So your perimeter for that is 12. The perimeter of the triangle is 12. I also need big B. What's the big B formula for this? 1/2 base times height. What's the base and the height? 1/2 times 4 times 3, right? Base and the height? 4 times 3. So big B of the triangle is 6. So I have these two things that I need. And I can go in here and start substituting. So the perimeter, which I just found, is 12. What is the height? 2 or 3 or 6? I don't know where the whole or 6. That we're finding the triangular prism. What did you write on the top of that left-hand page? The height is the distance between the bases. What is the distance between the bases here? It is 2. This is the height because this is the distance between the bases. Plus 2 times big B, which I just found, which is 6. So this is 24 plus 12. So the surface area of the triangle is 36, right? And I'm not done, so I'm not going to worry about units just yet. Everybody good with that? Okay, so now we're going to find the surface area of the rectangular prism. That also is perimeter times height plus 2 times big B. So my perimeter, what do I add for perimeter? 4 plus 2 plus 4 plus 2, right? So my perimeter is 12. It is a coincidence that these two numbers are the same, by the way. Total coincidence. So if you accidentally use the wrong one, you'd be okay here, but that's a coincidence. All right, then big B, what's your big B formula? Base times height. And what's the base and the height? Of what? What do I want the base and the height of? The rectangle. What's the base and the height of the rectangle? 4 and 2. So this is 4 times 2. So big B for the rectangle is 8. Okay. So I come back over here and substitute that in. My perimeter is 12 times, what's the height? 3. It's the distance between the bases here. Plus 2 times big B, which is 8. So this gives me 36 plus 16. So the surface area of the rectangular prism is what? 52. Okay. So now once you have this stuff, you go and you look at your plan. All right, I had to find the total surface area of the triangular prism. I got that. I got to find the total surface area of the rectangular prism. I got that. I'm going to subtract off 2 rectangles, which sometimes is a base and sometimes is not. So sometimes that's something you got to go off and find. Do I have to go off and find the area of this rectangle that I'm referring to? No, because that is big B right here, right? And so in the end, I just follow my plan. That's what some of you aren't doing so well. You write a plan, you do work, and then at the end, you just make stuff up. I don't get it. So make sure you do what you told yourself you're going to do. So the surface area of the triangular prism is going to be 36 plus the surface area of the rectangular prism, which is 52, minus 2 times 8. So what's 36 plus 52? Oh, it's 88. So this gives me 88 minus 16. So we get 72. So your total surface area in the end is 72 centimeters squared. So you've got to have a plan, which means you have to understand the figures. Then you have to be able to go and find the pieces and put them together and take them apart correctly. We good? You only have like one composite figure today because we don't have many more figures just yet, but basic idea of what's happening. Are we good? Any questions? Awesome.